The next topic we're going to look at with our rational expressions is adding and subtracting. And just like regular fractions, multiplying and dividing is easier than adding and subtracting because you don't need a common denominator to multiply or divide. You do need a common denominator to add or subtract, so we're going to take a look at that with our rational expressions as well. The first thing we want to do before we find a common denominator is make sure that our denominators are in factored form. We do not want our numerators in factored form because we're going to have to add and subtract in the numerator, which means we'll have to multiply them back out anyway. In the denominator, we're taking a look at what multiplies to positive 25 and adds to a negative 10. Those values are negative 5 and negative 5. Over in our second fraction, we have a GCF of 2. So we can factor that out, and that leaves us with x minus 5. Notice both of our denominators have an x minus 5. However, the one on the right is missing an x minus 5. We need a second one, so we're going to multiply by x minus 5 over x minus 5. Remember, when you multiply by a version of 1, you're not changing the value of the expression. We're just going to change what it looks like. Our right-hand expression also has a 2 in the denominator that the left one does not, so we're going to multiply our left expression by 2 over 2. Again, multiplying in the numerator so that we can add and subtract those like terms. In the denominator, we're going to leave it in factored form in case we can cancel anything out after we add or subtract. On the right-hand side, we'll have to FOIL to multiply these out. X times x gives us x squared. The inside and the outside will be like terms, so we will have negative 5x minus 4x, which gives us a total of negative 9x, and the negative 4 times 5 gives us a positive 20. All over, leaving it in factored form again. Now with subtraction, we will have to distribute that negative sign through everything in the numerator on that right-hand expression. So I'm going to do that next. And then we can add our like terms in the numerator. And remember, the common denominator stays the same when you add and subtract fractions, so we'll leave that piece alone. We've got a negative x squared. 2x plus 9x is 11x. And the minus 20. All over that common denominator of 2 times x minus 5 times x minus 5. Next, we'll factor that numerator to see if there's anything that we can cancel with the denominator to get our expression in simplest form. First thing I notice is that x squared is negative. When I set up t-chart, I want that x squared to be positive. Otherwise, I would have to use the AC method. All over my common denominator. Now I can use t-chart in that numerator, keeping that GCF of the negative sign, what multiplies to a positive 20 and adds to a negative 11. There are no numbers that work for that, so that is as simplified as we can get, and there's nothing that will cancel in the denominator. So you can either distribute that negative sign back through if you want to get rid of those parentheses in the numerator, or go ahead and leave it in factored form. The denominator I would just leave in factored form. Again, no use doing more work than you have to. Finally, let's take a look at our domain restrictions. The entire time, the only things we had in the denominator with a variable was that x minus 5 term. The 2 was also in the denominator, but 2 can never equal 0, so we don't have to worry about that with our domain restriction. So we have x cannot equal 5. And our second example involves complex fractions. This is when you have a fraction over a fraction, and to be perfectly honest, it's no different than when we divided our rational expressions yesterday. It's just that we have a fraction bar for the divide sign instead of a divide sign. So let's take a look at how we will start to simplify this. The numerator is already factored, but in our denominator we will have to add those fractions. So to get a common denominator, my right-hand expression needs an x minus 4 in the denominator, and my left-hand expression will need an x plus 1. So this will be all over, distributing that 1 through the x plus 1, I get x plus 1. Distributing the 3 through the x minus 4, I get plus 3x minus 12. I only recommend using this shortcut when it's addition of fractions. When it's subtraction, distribute the negative sign first, like we saw on example 1. And then we can put this all over our common denominator of x plus 1 times x minus 4. Our numerator again is still 3 over x minus 4. All over, adding those like terms, we have 4x minus 11 all over that common denominator. The 4x minus 11 does not factor, so there's nothing we can cancel before we divide. So I'm going to multiply by the reciprocal. My numerator, 3 over x minus 4, times the reciprocal of that denominator. So the x plus 1, x minus 4 flips to the numerator, and the 4x minus 11 flips to the denominator. Now we've got our x minus 4's that will cancel, and we can go ahead and distribute in the numerator since it's a basic just multiplying by 3. We get 3x plus 3 all over 4x minus 11. Finally, let's take a look at our domain restrictions. We started off with x minus 4 in the denominator, as well as an x plus 1. So far we have x cannot equal 4 and x cannot equal negative 1. Let's take a look at if anything else ended up in the denominator as we were working through. Up until this step, the answer was no, but here we have a 4x minus 11 in the denominator. So now we're going to set that as part of our domain restriction as well. Solving that by adding 11 to both sides and dividing by 4, we have x cannot equal 11/4 as well. You've got 2 U-Try questions. Do the best you can with these and bring any questions you have to class.